Problem solving requires that we look at information with our eyes, actually look at it. Neuroscientists have found that we can study this information processing by tracking where the eyes look. It seems as though we spend a significant amount of time when problem solving looking at information that is congruent with our understanding of the world. In this study published in Mind, Brain and Education, eye tracking is used to observe what types of information successful and unsuccessful problem solvers focused on in science problems. Problem solving is widely applied in science education to evaluate students' learning achievements. To solve a problem, you need to select information from the problem and integrate it with the knowledge you have on that topic to find the solution. Accordingly, information processing is an essential prerequisite during problem solving. Before students enter the classroom, they usually hold some intuitive ideas about the natural world. After they come to school, they start to acquire scientific knowledge, which will change their conceptual understanding. However, conceptual change is not achieved momentously, and students usually need to experience a learning progression to accomplish it. Researchers have proposed the minor and major changes in a concept. Minor change in a concept is thought to consist of additions or deletions of links to knowledge, which is easy to achieve. However, major change in concept, which is usually termed as conceptual change, requires not just the additions or deletions of links to knowledge, but the widespread reorganization of knowledge around new principles. Students usually develop some common misconceptions in science, which are resistant to change. Based on these findings, researchers propose that prior misconceptions coexist with scientific concepts even after achieving conceptual change. A concept of inhibition of misconception has been proposed. Researchers found that students required more time to correctly solve problems of conflicting misconceptions compared to problems without the conflicts. They suggested that the more reaction time was used to inhibit the misconceptions. Researchers compared the differences in information processing between students who held the intuitive misconception and those who achieved conceptual change. It showed that students usually selected information based on their current conceptual understanding. A convenient way to study information processing of problem solvers is to monitor their online eye movements. Previous studies have found that particular eye movement patterns correlate with success in problem solving. It was predicted that visual attention allocation may differ depending on the level of conceptual change of the students. Students who require the scientific concepts will attend to relevant information in problem solving, whereas students who hold the misconceptions will turn to irrelevant information based on their misunderstandings. The study used eye tracking to determine what information students looked at when solving a number of physics problems. Students who solved the problem correctly paid more attention to relevant scientific knowledge, but paid less attention to irrelevant. On the contrary, students who are unsuccessful in solving fixated on irrelevant information for a long time, but failed to select the relevant information associated with scientific concepts. Researchers overlaid visual cues on diagrams to direct students' attention to relevant information as they were solving conceptual physics problems. They found that attentional cues, which highlighted the relevant information, significantly improved students' abilities to solve these problems. Results exhibited that for the successful problem solvers, visual attention significantly differed between junior and senior students. Although both of them successfully solved the problem, the beginners might still be confused by the misleading information, thus need to struggle between the two conception systems and recognise the appropriate one to obtain the correct answer. Comparatively, for senior students, their increased domain knowledge and developed problem-solving skills made them more efficient to concentrate on scientific information, but inhibit irrelevant information. Overlaying visual cues on relevant information could direct students' attention to appropriate information and strengthen their understanding of scientific concepts. In addition, it might be advantageous for teachers to require students to mark out the key information explicitly themselves when solving problems. Bias inhibition training could be designed in science education practice. For example, teachers could emphasise conflicts between the common misconceptions and scientific knowledge. Conscious realisation of misconceptions is a basic condition for conflicts detection and inhibition. Teachers should encourage students to explain what information they applied to solve the problem in class. Much credit to all of the sources and authors from which I reported on their work. For further information, please feel free to leave a note in the comments. If you found this video helpful or informative, please hit the like button. If you want to see more videos on educational neuroscience, please subscribe. Thank you for watching.